All right, let's talk about how we can start checking these assumptions. There are a lot of graphical techniques. You don't need to use all of them, but I just demonstrate a couple of, a few of them. I tend to rely on QQ plots. Box plots. Uh, this box plots are good for showing you something that's, I mean, you can if it doesn't look like a box with that's symmetrically made, then that's symmetrical, then it's non-normal. Um, The skew you can determine by where the outliers are. The outliers are those little dots. So we would have a positively skewed distribution. This can also help you find out if you've got an odd data point. Like if you look at the top graph, which is a distance from mother in this culture, you can see that there was one that was really, really, really far away from mom. So that might be one that we go in and we say, hey, maybe we've got a data entry problem here. Maybe something was incorrect. Similarly, histograms will show the shape. Again, you can see how everything's piled up down at the bottom part, indicating positive skew. QQ plots I like. This graphs the actual distribution, which are the dots, against what a normal distribution would show, and that's what the straight line is. And in both of these cases, you can see lots of deviation from the straight line, indicating that our data are skewed. All right. Skew and kurtosis commands. And again, up top, I have the command incorrect. It's just Kurt. I messed that up in my code as well and had to go redo it. For each of these, what we're going to do is we're going to test the original variable. And this gives us a confidence interval. And that's the last two values here. We want to ask if 0 falls inside that confidence interval. If 0 doesn't fall inside the confidence interval, we have evidence that we've deviated substantially from normality. And if you just scroll through these, you can see that these are all situations where 0 does deviate. Where 0 does not fall inside the confidence interval. So we have problems with skew and kurtosis. And as I mentioned, if you have problems with skew, you're probably going to have problems with kurtosis. All right, homogeneity of variance. We could use our old friend, the tapply command here. This shows us for these 3 countries, the differences in the variances between each of them. And one thing we can see here is the variances in Samoa tended to be about 100 times or more large than those in the smallest cell, which was Belize. So we can see that's a pretty big violation of the 4-to-1 rule by an order of magnitude.